Welcome back, students. Today we are going to discuss about the TCP protocol and its services. So before this video, we have discussed about the transport lab services and the port number. So let's start with the TCP protocol services because there is a separate question is being asked in universities. Okay. So here, the very first slide is what the why TCP, that is TCP protocol. Then TCP is what a transmission control protocol. The long form of TCP is or transmission control protocol. It is a standard that defines how to establish and maintain a network conversation through which the application programs can exchange the data. It means, so if we have the two processes on the network or let's say on the host, so in between these two processes which are running on the different hosts, so they require some communication path, and that communication path is going to be established by a TCP protocol. And TCP works with the Internet Protocol, which defines how computers send the packets of data to each others. So TCP make a use of the IP protocol, where IP is a connectionless and TCP is connection oriented. Okay, we'll discuss how it is going to be tackled with these two protocols. This together, the TCP and IP are the basic rules defining the interface. So whenever there is a communication happens in the process to process communication happens, that time TCP must establish the connection and that rules to be provided, the regulations to be provided, and that is going to be provided. This Internet Engineering Task Force, that is IETF, define the TCP in the RFC standard number as documented 793. So in the 793, everything is available about the TCP protocol. TCP used for the organizing a data in a way that ensure the secure transmission between the server and client. So as we have discussed about, there can be possibility to communicate from server to client via server client paradigm, where the request and response protocol can help us to communicate this one. Okay, they can take the guarantee that they can ensure assurance that the secure transmission can be happen. It guaranteed the integrity of data sent over the network also, regardless of the amount. So there is a no any size of the data amount data to be transmitted with the help of transport layer with the help of TCP. Any size of data can be transferred. For this reason, it is used the transmit data from one other higher level protocol that requires all transmitted data to the two arrives. Okay, so here these are the basic requirement of this particular TCP protocol. If you go with the diagram, guys, here there is a position of TCP protocol where TCP protocol is a transport layer protocol, where upper layer is application layer and the lower layer is what the internet layer or maybe the network layer where the TCP is lies. Okay, so let's start with the TCP services. Now, once we discuss about this prerequisite, what we have, what the TCP features and what the TCP actually it is. So TCP is a connection oriented protocol. TCP required that connection between two remote points is established before the sending data. We know that the port address, port number. So if the any process running on the port, so that particular process to be wanted to communicate, and that is going to be provided by the TCP protocol, and that is connection oriented. In this connection oriented, very first what we have to do, we have to establish the connection. Secondly, we can transfer the data. Okay, so in this direction establish the connection, and then the connection termination can be done. TCP is reliable protocol, that is the receiver always send either positive or negative acknowledgement about the data packet to the sender. So it will definitely positive or a negative acknowledgement can be sent from the receiver, so that the sender always has a bright clue about whether the data packet is reached the destination or it needs to reset. Because unnecessary, if the sender is sending data to the receiver and receiver is not responding to the sender always retransmit data. That retransmission can create a congestion, can create a chaos on the network. So it is better, and it is function by default function of the TCP protocol, that the acknowledgement policy is available. TCP ensures that the data reaches at intended destination in the same order it was sent. So here, as the TCP is the connection oriented protocol, so if I'm sending, let's say 1, 2, 3 in this fashion, so definitely at the receiver end also 1, 2, 3 is going to be received. The dependency is strong. Dependency is strong. There is no independency. The TCP provide error checking and the recovery mechanism. We'll discuss one by one later on. The TCP also provide the end-to-end communication. TCP provide the flow control and quality of services. TCP operate in client server point-to-point mode, and TCP provide full duplex server service or servers. That is, it can perform the roles of both receiver as well as the sender. So full duplex is what at the same time more two sides can be sent to each others. These are the some features about the TCP protocol. So let's start the services of the TCP protocol. So here there are services available: process to process communication, stream delivery services, full duplex, multiplexing, demultiplexing, connection oriented service, reliable service, flow control, error control, congestion control. Let's take one by one these. Okay. So here there is a first service, and that process to process communication is the service. As with the UDP and TCP, these two both the protocols provide the process to process communication using port number. So we have discussed the port number and the process to process communication in transport layer. Okay, but here as a quickly we'll discuss. Consider this is computer, center computer, and this is receiver computer. Computer to computer connection can be happen with the IP address, but the processor running on that particular computer which required some port numbers. So process to process communication can be tackled via this particular TCP protocol. This is what the process to process communication. Let's say an example. Let's say I have a Facebook application which is running at my end, and another at another in my friend end, that is a Facebook application. So Facebook to Facebook chatting and Facebook to Facebook conversation is what the process to process communication. Then second service, what the stream delivery service. This is what the core service of the TCP protocol. Please pay attention over here. Like unlike the UDP, TCP is also a stream-oriented protocol. It means what? We'll discuss. The TCP protocol allows the sending process to deliver data as a stream of byte and allow receiving process to obtain data as a stream of byte. Okay. Now, the TCP create an environment in which the two process seems to be connected by the imaginary tube that carries their byte across the internet. Let's consider this is the sending process and this is the receiving process. This sending and receiving process wanted to communicate with each other. There, the logical tube is going to be provided, and that is what the logical tube, that communication tube, through which the communication can be happen with the help of with that particular TCP protocol. Okay, here the stream oriented protocol is allowed to sending the process to deliver data as a stream of byte. It means what? What the consecutive bits are going to be bytes are going to be sent from that particular imaginary tube. How it is going to be transferred, we'll discuss later on. Okay. Now consider how this stream delivery service can be achieved. Here, sending and receiving buffer is happening. Okay, sending and receiving buffer. Sending and receiving process may not necessarily write or read the data at the same rate. Okay, because the rate of the both the end, the producer and consumer rate always differ. So TCP required buffers for the storage so that flow of the data, flow of the data or information can be controlled or can be balanced. There are two buffers: the sender side buffer and the receiver side buffer, one for each direction. So one way to implement the buffer is what? We have a circular array with the 1 byte location as shown in figure. So this is what the buffer. This is what the buffer. Okay. The buffer may be a hundred or thousand of byte depending on the implementation. So we can have thousands of byte of buffer. So let's take very first buffer is what the sending buffer, because we are discussing about the stream byte. Now, in this figure, show that the movement of the data in the one direction at the sender end it has the three chambers. Okay, if we see the diagram, there are three sections of this particular buffer. The white section, so this portion is what the white section, guys, of this for the sender buffer. Okay, would contain the empty chamber that can be filled by the sending process, that is producer. Whenever the item produced, whenever the messages are produced, the DVT will be kept at particular this white section. Then the colored area, it hold the byte that have been sent but not at acknowledgement. So this is what the second one, the bytes had sent but not at acknowledgement by the receiver. The TCP send keep these bytes in the buffer until the receiver has acknowledged. Okay, it means what? When once the acknowledgement is received from the receiver, till that time, that the data is going to be stored in this particular buffer. Then there is a third category, that is shaded area. It contains the byte to be sent by the sending TCP. So here in this area, whatever the bytes are wanted to send, that is going to be kept over here. So this is what the sender side. But if you go with the receiver side, in the receiver side, the buffer has the the same, we can say the operation of the buffer at the receiver is simpler. And the circular buffer is divided into two areas, that two areas shown as the white and the color. So let's say white area containing the empty chamber. So this area is what the empty chamber, to be filled by bytes received from the networks. Okay, whatever the sender is sending, then that time only is going to be filled. Then color section is contained the byte that can be read by the receiving process. Okay, and this is what the read by the receiving process, this chamber. When the byte is read by the receiving program, the chamber is recycled and added to the pool of empty chamber. Okay, so here from this 1 minus is going to happen, and the 1 plus 1 plus is going to happen. This kind of scenario is available. So this stream delivery services is going to be achieved via such kind of mechanism. Okay, then there is a concept, guys, and there is concept is what the segments. So the unit of transport there is what the segment. Unit of transport is what the segment. So here, although the buffer handle the difference between the speed of the producing and the consuming process, it needed one step before we can send data. So in the earlier slide, what we have discussed about the buffer, and we committed that the buffer is going to be provide control the producing and consuming rate, but still we need to do the process, and that process what the segment. So what that segment it is, at the transport layer, TCP group a number of bytes together into a packets called a segment. Number of bytes, whatever the information is available with us, so that is going to be binded in the byte, and that bytes combinedly called as what the segment. From the upper layer, it will receive some payload, and that is going to be combined together, and that called as what the segment. Then TCP adds the header to each segment. Okay, whatever the segment is going to be created. So in order to have a track to that segment, TCP added the header for control purpose and deliver these segments to the IP layer for the transmission. These segments are encapsulated in the IP datagram and transmitted. The entire operation is transparent to the receiving process. Although all of these are all of these handled by TCP sender, with the receiving application process unaware of the TCP activities. So receiving process never knows about what is going to happen at the sender side. Note that segments are not necessarily all the same size. So segment size is never going to be same. In this figure, for simplicity, that's shown the segment carrying 3 bytes and the other carrying 5 bytes. If you go with this diagram, so here there are 3 bytes are available, segment 1, and segment end is what the 5 bytes are available. So if I can say whatever the data available from the upper layer, let's say this is what the data available from the upper layer, and this data is going to be separated into what the kind of segment, and this segment can be of variable size. Okay, this segment can be variable size. Now this segment may be received out of order, lost and corrupted, and resent also. So this is what the segments available with this particular TCP protocol. Then there is another service available of the TCP protocol, the full duplex communication. This offer the full duplex communication where data can flow in both direction at the same time. It means what? And sender and the receiver can send data at the same time. Sender can also send data on same time. Each TCP endpoint has its own sending and receiving buffer. We discussed sending buffer and receiving buffer, and segments move in both directions. This is also possible. Another service is multiplexing and demultiplexing. Like UDP, TCP perform the multiplexing at the sender side and demultiplexing at the receiver side. However, since the TCP is connection-oriented protocol, the connection need to be established for each pair of the processes. It means what? Here, if let's say 20 of processors available, so many to one is what the multiplexing, whereas one to many is what the demultiplexing, guys. So here they are splitting the channel into different the endpoint is going to be split to that to provide the services. We have discussed this in a transport layer. Then another service is what the connection oriented service. As we know that TCP is what the connection oriented protocol. When the process at the site A wants to send the data and receive data from another process at the site B, the following three pages to be occur. The very first, what we have to do, we have to establish a virtual connection between them. Then data are going to be exchanged in both direction, and then third, that connection to be terminated. So as a connection oriented, We have to establish the connection first of all. On the basis of that only the data can be transferred, and that part to be available, freely available for the others, so termination to be happen. Here there is a note the about this particular connection oriented service. This is the virtual connection, not a physical connection. So we are not creating a physical path, we are creating a virtual path. Okay. And TCP creates an stream oriented environment in which it accepts the responsibility of delivering the bytes in order the other sides. So whatever the order is followed, let's say 1 2 3, it is going to be received by 1 2 3 only in this manner. So segment dependency is fully available. The segments cannot travel with their own choice. There is one sequence is supposed to be followed. So these are also the services. Apart from these services, there are some another services like a reliable service. So TCP is what reliable because it is connection oriented. Now, and it also get the acknowledgement mechanism to check the safe and sound arrival sound arrival from the data. It means what? It is more available in the error control. Reliability service is more explained in the error control part. So in order to have a reliable services, what we have some number system. And number system, well, this is what very important part. Although the TCP, that is software, keep tracks of all the segment being transmitted or the received, there is no field of segment number value in the segment header. So there is no any segment number value header field is available in segment header. Instead, they are used two fields called a sequence number and the acknowledgement number. So directly they don't have a segment number, but what we have the sequence number and the segment number in the TCP format. These two fields are referred to the byte number and not a segment number. It means what? Let's say byte number. So TCP numbered all the bytes, that is octet, that are transmitted in connection, that is bytes. Numbering is independent in each direction. When TCP received a byte of data from the process, TCP stored them in a sending buffer and numbered them. Okay. So whatever the buffer is available with, let's say sender. So sender received all this content and numbered them. The numbering does not necessarily start from zero. It is not required to start from 0, 1, 2, 3, but instead TCP choose an arbitrary number between the 0 to 2 to the power 32 minus 1 for the numbering of the first byte. It can be anything. So this byte number is also important, that bytes to be numbered, and byte how many bytes to be numbered, so that we can club that bytes into together and that will become a segment. Then second is what the sequence number. After bytes have been numbered, the TCP assign a sequence number to each segment that is being sent. The sequence number for each segment is the number of the first byte of data carried in the segment. If we go with this diagram, if you go with this logic, so we can say if there are, let's say, upper layer data is receiving, now here we are getting some data. So here we are numbering this byte, okay, and by combining this byte, what we are creating a segment. We are creating what the segment. So segments comprise of number of bytes, and that number of bytes comprise of some kind of information. That is what the thread, and that is going to be numbered with the sequence. That is going to be what the sequence number, that segment. Then third is what the acknowledgement number. The acknowledgement number is a cumulative. It means what? Which means that the party takes the number to the last byte that it has received. Safe and sound add it adds the one to at the end and announce this is some as acknowledgement number. It means what? If I'm sending as a, let's say, sequence number is 100, and what I am getting 101 will be my acknowledgement. Okay, 101 is what the acknowledgement. So x and x plus 1. This is what the logic over here. So these are the also services available with the TCP. Apart from this, the TCP also provide the flow control, error control, and congestion control. So flow control, error control, and congestion control have a separate videos. So let's take in a quick fashion. So flow control, consider the producer consumer, or let's say data rate. So definitely the data rate of the sender and receiver may be different. So in order to balance the data rate, what we required a flow control. Okay, where the buffer can be provided, where the buffer can be provided. And more about this, the sending TCP control how much data is accepted from the sending process. The receiving TCP control how much data can be sent by the sending TCP. And this is done to prevent the receiving from being overwhelmed the data. So it means what? If the high rate data is available, so definitely the data can be lost, and that stop that data loss, we required some kind of buffers so that the congestion can be reduced and the flow can be maintained. The numbering system allow TCP to use the byte oriented flow control. The number system is available. With the help of this number system, we can also help to flow control. Then second is what the error control. To provide reliable service, earlier we discussed the reliable service. TCP implement the error control mechanism. Although error control consider the segment as a unit of data for the error detection, like loss or corrupted segment. The error control is a byte-oriented concept. So here, error control mechanism is also provided. There are some policies are available: open loop, closed loop. There are transmission policies are available. We have separate video to this particular error control also. We can see in that in detail. Then congestion control. So here also, unlike a UDP, TCP is what take into account the congestion in the network. The amount of data sent by the sender is not only controlled by the receiver, that is flow control, but also it is intermediate. It determined by the level of congestion, if any, in the network. Also here, the sender not only sender can work on this particular congestion control, but also the different in between network is also uh, here responsible for the congestion control, where what we have maximum segment number, maximum segment size is MSS field is available as like a IP. What we have maximum transport MTU. What we have MTU here MSS is available, and at the network layer also the congestion control is going to be controlled. So how this is going to be controlled? We will discuss in a separate lecture. So in this lecture, in this video, what we have discussed the transport layer protocol and the transport layer protocol services. Specifically, you focus on the segments because that segment is what very important. Apart from this segment, process to process communication, connection orientation, flow control, error control, data control, multiplexing, demultiplexing, encapsulation, all our techniques are available. We have discussed all these things. Thank you. Thank you.